The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Alrighty, today we're going to take a look at section 9.2, but before we do that, we'll look at questions from 9.1. I have one question that somebody emailed in. This is section 9.1, part 2, problem number 1. And it says this, it says, find each function value if possible. Do not use a calculator. If the answer is undefined, enter undefined. And it says h of t equals the square root of t squared plus t minus 4. And we are to find h of negative 5. So that would be the square root of negative 5, the quantity squared, plus negative 5 minus 4. Negative 5, the quantity squared, would be a positive 25, and then plus negative 5 minus 4 would be, let's see, 25 minus 5, 20 minus 4 is 16. So the square root of 16, which is 4. Be careful, be sure that when you take t and square it, negative 5, the negative is inside the parentheses, so squaring it, negative 5 times negative 5 is positive 25. Okay, so that was that question. Actually, you know what? Well, yeah, Rick, were you able to see that? Did I have the right screen up?
Yeah.
Hello?
Yes.
Somebody? Sorry, I had my volume turned off. Go ahead, Carly. Is this?
We said yes.
Okay, sorry, the volume was turned all the way off. I had that happen once before. Okay, any questions from any of you folks concerning 9.1 from Monday?
Yeah, I had a question on one of them on number 2.
Okay,
For part A.
Can you give me the question or do you want me to look it up?
It's g of x equals the square root of 9 minus 8x, and a is g of negative pi.
Negative pi? So like
Yeah.
that?
Yeah.
Okay. Are we supposed to evaluate it with a calculator or just get an exact number?
It said round to the nearest 10,000.
10,000, okay. All right, so g of, and you said negative pi?
Yes.
It's going to be the square root of 9 minus 8 times negative pi, which would be the square root of 9. Minus 8 times negative pi would be plus 8 pi, okay? So on my calculator, I'm going to find the square root. Then I'm going to put in a left-hand parentheses if it doesn't automatically put it in. Mine does. 9 plus 8 pi. Are you able to find the pi button on your calculator? Is anybody having issues with that?
I wouldn't know yet. My calculator hasn't arrived.
Okay.
Although it's supposed to arrive today.
All righty. Let's see. I guess I would say, go online, find a calculator, type in scientific calculator, find one that has a pi button on it. You should be able to find one online and use it there. If that isn't working for you, Abel, let me know, okay?
No worries.
All right. Anyway, so I've got 9 plus 8 pi, close it up, and I get 5.84. 2323227, etc. So the nearest 10,000, this is the tenths, hundreds, thousands, 10,000s. this would round down, so you get 5.8423. Okay with that?
Yeah, thank you.
Okay, tell you what, let's do this. I'm going to see what I can find here. Scientific. Here we go. Okay, so just as an example, I just typed in scientific calculator and this one came up. And you see right here, there's a pi button.
Yep.
So for this, let's see, square root, and then there's a left-hand parentheses already in there, 8. I said 8, I clicked 9 plus 8 pi, close it up, and there you go. So there's just an example of where you could do it with a calculator online until yours arrives. Okay, real good. Let's go back here. And so any other questions from people before we go on? All right. What I want to do right now is I want to review some properties, some shortcuts that we haven't talked about this quarter. They would, if you took Math 85, you would have covered them. We started in chapter 5.4 this quarter. And in chapter 5 and section 5.1 and in 5.2, they cover properties of exponents. I want to review those today because we're going to be using those in chapter 9, which we'll get to here eventually. So I want to go over some rules. And as I say, if you want more on the subject, you could go in and look at section 5.1 and 5.2. Okay, first of all, let's say we've got a to the m times a to the n. So we are multiplying two powers with the same base. In this case, our answer is going to be that base raised to a power which is the sum of the two exponents. So for instance, x to the 7th times x cubed would be x to the 7 plus 3 power, or x to the 10th power. Y to the 4th times y to the 2nd would be y to the 4 plus 2 power, or y to the 6th power. Any questions about that rule? Okay, so that's one of them. Another rule, let's say we have a power divided by a power. So we're dividing two powers with the same base. So now we get the base with the top exponent minus the bottom exponent. So for example, x to the 7th divided by x to the 3rd would be x to the 7 minus 3 power, or x to the 4th power. Y to the 9th divided by y to the 2nd would be y to the 9 minus 2 power, or y to the 7th power. Any questions about that particular rule? Okay, I'm going to turn to chapter 5 just to make sure I don't forget any of these rules when I'm reviewing them for you. Okay, let's see here. Another rule. Let's say we've got a power raised to a power. In this case, we multiply the exponent. So let's say we've got x cubed to the 4th power. That would be x to the 12th power, or y squared to the 8th power would be y to the 16th power. I want to point out a difference we need to be careful of, okay? X cubed to the 4th power is x to the 12th power, but x cubed times x to the 4th power would be x to the 7th power. So don't get those two confused. Let's see here. Got that one. Okay. Let's say we have a product raised to a power. Then we attach the outside power to each factor inside. So let's say I've got x, y, the quantity cubed, that's x cubed, y cubed. Or maybe I've got 2x to the fourth power. That's 2 to the fourth power, x to the fourth power. I could go further. 2 to the fourth power is 2 times 2 is 4, times 2 is 8, times 2 is 16. So we get 16x to the fourth power. So we've got a product raised to a power. Any questions there? All right, let's say we've got a quotient raised to a power. Again, we attach the outside exponent to the base in the numerator and the base in the denominator. So let's say I've got x over y, the quantity cubed, that's x cubed over y cubed. And let's see here. Done that one and that one. Okay. A variable raised to the 0 power is 1. A variable raised to the 1 power is just the variable. It's the same thing. In other words, there's an implied 1 exponent on the variable in this context. Okay. Now, let's see. If you've got a power raised to a negative exponent, that's 1 over the power raised to a positive exponent. If you've got a power like this, let's say, the x to the negative 3 power goes down below and becomes x to the positive 3 power. The y to the negative 2 power down below goes up above and becomes y to the positive 2 power. So if you have a base with a negative exponent, you can move it across the fraction bar and change the sign of the exponent in this context. And in general, let's see, it looks like this: x to the negative n equals 1 over x to the n. Okay. Also, let's say we've got a quotient to a negative power. Then you could just take the reciprocal and change it to a positive power, and then go on and attach the outside exponent. And I know that's kind of a quick review. Like I say, if you need more review on that, take a look at section 5.2, or visit me during my office hour, or email me if you want some more specific examples. I'd be happy to do that. All right, so now we're going to go on to section 9.2. And we're going to apply these rules, only now we're going to expand what we can use as exponents. Now we're going to deal with having exponents that are fractions. Okay, give me just a second here. So let's say I have the cube root of 8. What is the cube root of 8? Well, that's 2, because 2 times 2 times 2 is 8, all right? But I can also take the cube root of 8 and write it as 8 to the 1/3 power. The index becomes the denominator of a fraction exponent. Let's say I have the cube root of 4 squared. That would be 4 to the 2/3 power. So the exponent is still in the numerator, but the index is in the denominator. Okay. Any questions about that? Let's go to our calculator and put in the cube root of 8 and come up with 2. So now we talked yesterday about there's a square root, or not yesterday, but Monday, and then there's an x root button. So what I want to do is I want to put a 3 in, then get the x root, then put in 8, and then put it equal, and I should get 2. because basically I'm taking the cube root of 8, which is 2. So if you have a calculator available, try that. If you don't, then maybe try that later when you do. Okay. Now, let's take a look at this. It says evaluate each expression, 81 to the 1/4 power. So this is the same thing as the fourth root of 81. But now what I'm going to use, there should be a little caret key that's a power key. So on your calculator, you're going to put in 81, then this little key, then parentheses 1 divided by 4, close parentheses. So basically you're taking the fourth root of 81 and you should come up with an answer of 3. Now, the biggest mistake students make is they do that and they leave out the parentheses. By leaving them out, basically what you're doing, if you put this in, that's like saying 81 to the 1 power divided by 4, and you're going to get what, 20.25, I think. Okay, so you've got to have a grouping symbol or parentheses around the exponent if there's more than one term in the exponent. Okay, so 81 to the 1/4 power is 3. Here's another way you could do it without the grouping symbol. 1/4 as a decimal would be 0.25. You could go 81 to the what, 0.25 power, or just 81 to the 0.25 power. Now you're not taking 81 times 1/4. You're raising it to the 1/4 power, which is equivalent of taking the 4th root. So in all these cases, you should get 3 as an answer. Okay. Let's see here. 32 to the 1/5 power. So that's the same thing as taking the 5th root of 32, which is 2. Again, on your calculator, you could put in this, and you should get a 2. All right, how about this one? 1/16 to the 1/2 power. So on your calculator, parentheses, 1 divided by 16, close it up. Little caret power key there. 1 divided by 2, close it up. The square root of 16 is 4, so the square root of 1/16 would be 1/4, or 0.25. Okay, now it says, simplify each expression. Assume that the variables can be any real number and use absolute value symbols when necessary. Now, earlier it said, assume the variables are unrestricted. Now they're saying can be any real number, basically the same thing. Variables, whether unless they tell us specifically, they can be positive or negative or 0. And again, we have to avoid taking an even root of a negative number. And if we do take an even root of a number, we can't get a negative answer. So it's all about even roots and negative numbers, the restrictions. Okay. This says the quantity 4x to the 4th power to the 1/2 power. So what we're going to do here is we have a product raised to a power. So this will become 4 to the 1/2 power, x to the 4th to the 1/2 power. We attach the outside exponent to each factor inside. Okay, now 4 to the 1/2 power, that's like taking the second root of 4, or the square root of 4, which is 2. Here we have a power raised to a power, so we multiply the exponents. 4 times 1/2 is 2. So we get 2x squared. Now, we took an even root, raising it to the 1/2 power is like taking the square root. So our answers can't be negative. However, 2 is positive and x squared, even if x is negative, x times x would be positive. So in this case, we don't need any absolute value bars. All right. Any questions there? Let's take a look at another example. X squared to the 1/2 power. A power raised to a power, again, you'd multiply the exponents. So this would be x to the 2 times 1/2 or x to the 1, which is just x. But again, we're taking an even root or a even power, so to speak, the 1/2, well, anyway, in the denominator. So we need to make sure x isn't negative, but since x is unrestricted, we have to use absolute value bars. Okay, let's say we've got x cubed to the 1/3 power. Well, this would be x to the 3/3 power or x to the 1 power or x. Here, I don't need absolute value bars. Since I'm taking a cube root, the answer can be negative. It's just when you're taking an even root that you have to avoid a negative answer. So I don't need absolute value bars there.
So you just multiply the exponent that it has on the side all the time.
Yeah, if you have a power raised to a power, you're going to multiply the exponents. So same thing here, same thing there. Yeah,
Okay.
power raised to a power. You okay with that?
Yeah, thank you.
All righty. How about this one? -16 q to the 4th power all to the 1/2 power. So that would be -16 to the 1/2 power, q to the 4th power to the 1/2 power. What is -16 to the 1/2 power? What's the square root of -16? Not real. We can't take an even root of a negative number. So we can't take a fractional exponent where the denominator is even, because this is the same thing as taking the cube root of -6, or excuse me, the square root of -16, which is not real. Now, this would be q to the 2nd power, but since the first part's not real, the whole thing's not real. Okay, how about this? 243 x to the 10th power all to the 1/5 power. So this would be 243 to the 1/5 power, x to the 10th to the 1/5 power. Let's see, 243 to the 1/5 power. Let's put that in our calculator. 243 to the 1 divided by 5 power, 243 to the 1 divided by 5 power. It comes out as 3. So this is 3x to the 10 times 1/5 would be 2. Now, I'm taking an odd root, so I don't have to worry about it. I don't have to worry about it anyway because x squared couldn't be negative. So there you go. Okay. How about this one? It says evaluate each expression. 27 to the 2/3 power. Now, first I'm going to do it on a calculator. 27 power key 2 divided by 3, close up. Let's see what I get here. I get 27 raised to the 2 divided by 3 power, and I get 9. Now, let's do it without using the calculator. 27 to the 2/3 power. That means we're going to take the cube root and we're going to square it. Okay, so the cube root and square it. What's the cube root of 27? What times itself is 27? 3. but that's going to be squared, which is 9. Let's do it a different way. Let's take it and let's square it first, and then take the cube root. Well, let's see here. 27 squared is 729. Take the cube root of that, and I still get 9. But notice this one was easier. This one I could do in my head. This one, not so easy. As long as they're both real, both the root and the power, you can do them in either order. So generally, it's easier to do the root first and then the power, just because then you're dealing with smaller numbers. Okay, let's see.
So then you just have to separate the numbers, right? Like how for the 27 2/3, and then you just separate it. So then you know what one's the root and what one's the.
Yes, yes. Let's see here. Let's look at this again. Consider this. What's if 27 to the 1/3 power squared? Wouldn't that be 27 to the 2/3 power?
Yeah.
So we're going the other direction. We're taking 2/3 and breaking it down into 2 times a third. So we can do this first and then that, or this first and then that. Okay.
Okay.
All right. What about this? Negative 100 to the 3/2 power. Now, be careful. We're taking a second root. So we're taking an even root. But the base is not negative 100. For the base to be negative 100, we'd have to have that, which is not what we have. Okay. So this is like 100 to the 3/2 power with a negative sign in front of it, since there's no grouping symbol capturing that negative. So let's see here. That's what, 100 to the 1/2 power cubed. I can do the root first. What's the square root of 100?
That would be 10.
10. What's 10 cubed?
1000.
Good. So final answer, negative 1,000. But now if it was this problem where the negative was included, this would be not real. Okay. So for instance, negative 2 to the 4th, negative 2 to the 4th. Here, this is 2 times 2 times 2 times 2 with a negative sign. Here, this is negative 2 times negative 2 times negative 2 times negative 2, which is positive 16. Okay. So if you want the negative sign included as part of the base, it has to be grouped. So, okay, how about, let's see here, 4/9 to the 3/2 power. So we've got a quotient raised to a power. So we're going to attach the exponent outside to both the numerator and the denominator. But now I could do the root and then the exponent, and on the bottom I could do the root and then the exponent, or the power, I should say. Okay, so what's 4 to the 1/2 power, or what's the square root of 4?
2.
What?
2.
2. So then I've got 2 cubed, which is 8. In the denominator, what's the square root of 9?
3.
And then I've got 3 cubed, which is 27. So final answer, 8/27. Now, you could punch all that into your calculator, but then you'd get some awful looking decimal answer, which you'd probably round off and then it would be wrong. So you want to get it exact. Okay. Let's continue here. Suppose I've got the quantity 27 a cubed b cubed all to the 2/3. 2/3 power. Okay, so that's going to be 27 to the 2/3 power, a cubed to the 2/3 power, b cubed to the 2/3 power. And the directions say all variables represent positive real numbers. In this case, it wouldn't matter because we're taking a cube root, which is an odd root, so it wouldn't matter. But let's see here. 27 to the 2/3 power, that's like 27 to the 1/3 power and then squared. What's the cube root of 27? So what's this piece of it? What times itself times itself?
9.
Right?
At 3.
Yes, so this would be 3 squared or 9. Here we have a power raised to a power. What's 3 times 2/3? 3 times 2/3 would just be what?
2.
So that's going to be a squared. And here's the same thing, b squared. Now, again, they told us the variables were positive. In this case, it wouldn't matter because the exponents are even, so they wouldn't be negative answers anyway. But you okay with that?
Yeah.
All right. Here's another one. 1/16 x to the 8th, y to the 4th, all to the 3/4 power. So we've got 1 to the 3/4 power over 16 to the 3/4 power, x to the 8th to the 3/4 power, y to the 4th to the 3/4 power. Okay, so we got each one of those pieces raised to the 3/4 power. Let's take this. What's the 4th root of 1? It's 1. What's 1 cubed? It's 1. Or what's 1 cubed? It's 1. What's 1 to the 1/4 power? It's 1. So all of this becomes 1. Okay. Let's take a look at this piece. 16 to the 3/4 power would be the 4th root of 16 cubed. What's the 4th root of 16? What times itself times itself times itself is 16?
2.
And what is 2 cubed?
8.
So
No, that
this,
would be. Wait.
you okay there?
Yeah, I just had a brain fart. That's all.
Okay, all right, that's okay. All right, and let's take a look at this. Oh, we're going to multiply the exponents. What's 8 times 3/4?
6.
So this would be x to the 6th. What about this? That would be y to the
3rd.
3rd. Okay, so I could write my answer like that, or I could write it as x to the 6th y cubed all over 8. So either this way or that way. Okay. Any questions there? Okay. Now, the directions here say change each radical to an exponential expression. So I've got the 5th root of the quantity 8abc. So that would be the quantity 8abc to the 1/5 power, because again, the index becomes the denominator of the exponent. How about this? The 7th root of the quantity 7p squared q, that would be parentheses 7p squared q all raised to the 1/7 power. Okay.
So for those, we don't have to work out the problem, just write them.
Right. They just want you to convert it from one system to the other. Correct. This says change each exponential expression to a radical. So we've got the quantity 6x cubed y to the 1/4 power. So that would be the 4th root of 6x cubed y. So we're changing the exponent to a radical form. And let's see, here's another one. The quantity x cubed plus y cubed to the 1/3 power would be the cube root of the quantity x cubed plus y cubed. Any questions there?
No.
Okay, let's deal with negative exponents. 49 to the -1/2 power. So that would be 1 over 49 to the +1/2 power. The 1/2 power is the same thing as the square root. So what's 49 to the 1/2 power, or what's the square root of 49?
How did you make it so it's positive? Because it was negative in the beginning. Or because it's squared?
Okay, when you have a negative exponent, you take the base and move it to the other side of the fraction bar, and it changes the sign of the exponent. That was one of the rules there we looked at the beginning of class today.
Okay.
All righty. So what is the square root of 49?
7.
7. There you go. All right. Now, notice a negative exponent does not produce a negative answer. It produces this reciprocal situation going on here. So be careful with that. How about 8 to the -1/3 power? That would be 1 over 8 to the 1/3 power, which is 1 over 2. Okay. How about 25 over, well, let's write that a little nicer. 25 over 49 to the -3/2 power. So that's 49 over 25 to the +3/2 power. I took the reciprocal, changed the sign of the exponent, but that's 49 to the 3/2 power over 25 to the 3/2 power, which is 49 to the 1/2 power cubed over 25 to the 1/2 power cubed, splitting that fraction exponent into 2 parts. What's 49 to the 1/2 power, or the square root of 49? That's 7, but that's still cubed. Let's see, 7 cubed. 7 cubed is 343. And then 25 to the 1/2 power would be 5, and that's cubed, and that's 125. So there's your final answer. So that was kind of a long problem. Any questions there? Okay, how about this one? 4 to the 2/5 power times 4 to the 2/5 power. It says simplify each expression, write the answer without negative exponents. All variables represent positive real numbers. All right, recall when you're multiplying 2 powers with the same base, you add the exponent. So like if I had x cubed times x cubed, that would be x to the 3 plus 3, or x to the 6th power, right? So this is going to be 4 to the 2/5 plus 2/5 power, which is 4 to the 4/5 power. So we're just adding the exponents. How about this one? 5 to the 1/3 power times 5 to the -5/3 power. So this would be 5 to the 1/3 minus 5/3, or plus -5/3, which would be 5 to the -4/3 power, which would be 1 over 5 to the +4/3 power. Okay with that? So again, we're using those rules that we looked at the beginning of class today. Let's see here. B to the 3/5 power times B to the 2/5 power, all to the 8th power. Order of operations, starting inside the grouping symbol first, we're multiplying two powers with the same base inside. So inside we would get B to the 3/5 plus 2/5 power, which is B to the 5/5 power, which is B to the 1 power, which is just B. So our final answer is just B to the 8th power, because everything inside turns into B to the 1 power, or just plain old B. Now, you don't necessarily have to write all these steps to get to the answer, but I want to make sure you understand how I got there. Okay. Let's see here. How about this one? 2 to the 5/6 power times 2 to the 1/3 power over 2 to the 1/2 power. So first of all, in the numerator, I'm multiplying two powers with the same base. So I'm going to add the exponent. So I'm going to get 2 to the 5/6 plus 1/3 power. But to add 5/6 plus 1/3, I need a common denominator of 6. So I'm going to get 5/6 plus 1/3. I'm going to multiply by 2 over 2 to make it into 2/6. So we end up with 2 to the 7/6 power in the numerator. Any questions about that? Okay, now dividing two powers with the same base, you subtract the bottom exponent from the top. So that's going to be 2 to the 7/6 minus 1/2 power. But now I've got 7/6 minus 1/2. So I need a common denominator of a 6 again. Now I'll multiply this by 3 over 3. 7/6 minus 3/6 is 4/6, which could be reduced down to 2/3. So this becomes 2 to the 2/3 power. So that whole thing simplifies down to that. Good review of adding and subtracting fractions there. Or maybe not a good review. Maybe you're going, ah. Okay. Continuing on, let's say we've got this situation. Y to the 2/5 power times the quantity y to the negative 2/5 plus y to the 3/5 power. So we're going to distribute here, okay? So that's y to the 2/5 times y to the negative 2/5 plus y to the 2/5 times y to the 3/5. Here, we're multiplying two powers with the same base, so we're going to add the exponents. We get y to the 2/5 plus negative 2/5, which is y to the 0 power, which is 1, plus y to the 5/5, which is y to the 1 or y. So our final answer is just 1 plus y. This says use rational exponents to simplify each radical. All variables represent positive real numbers. So what we're going to do, we're going to take a radical, we're going to convert it into exponential form, we're going to simplify it, and then we're going to move it back into radical form. So this would be 7 to the 3/6 power, which would be 7 to the 1/2 power, which would be the square root of 7. So this simplifies into that. Any questions there? Okay. We're going to do the same thing here. The 10th root of x squared y squared would be x squared y squared to the 1/10th power, which would be x squared to the 1/10th power, y squared to the 1/10th power, which would be x to the 1/5, y to the 1/5, which would be the 5th root of xy. Now, sooner or later, somebody's going to say, well, couldn't you just take that divided by that? Yes, we'll get there. It's coming. Okay, how about this one? Let's see here. The 4th root of the 2nd root of x. So that would be the square root of x to the 1/4 power, which would be x to the 1/2 to the 1/4 power, which would be x to the 1/8 power, which would be the 8th root of x. So this becomes that. So I converted that into exponential form, converted that into exponential form, multiplied the exponents, converted it back into radical form. Have I ruined your evening? I guess we'll find out. All right. Well, that's all I've got for you for today. So I'm going to stop the recording.